All right. So sorry about that late recording. We're talking about volume of prisms and cylinders today. And so all we really missed out was our volume definition. Volume is the space inside of a three-dimensional figure, not the space around it like surface area. And it's measured in cubic units. The volume formula for any prism or cylinder is V equals capital BH, with capital B standing for the area of your base. So it's going to be one of these three: length times width for a rectangle, 1/2 BH for a triangle, or pi r squared for a circle. We did the first one here, and we had the option to choose whatever side we wanted as our base. Because it's a rectangular prism, you can choose any of the rectangle sides. What kind of shape is example B? Xander? It's a triangular prism, so I have no choice but to choose the triangle as my base. Just like when we were doing surface area, you had to call that side your base. So the formula for the volume of any prism is capital B times H. And to find the area of that triangle, Xander, what numbers do I have to multiply together?
5 and 12.
Okay, what else?
9.
Nope. For the area of that triangle. Okay, that works. And then you said the distance between those two bases was how far? 9. Okay, so they're 9 meters apart. Remember, the height of a prism does not necessarily mean up and down height. I cannot stress that enough. I say it like every single time. Okay, so now I'm going to multiply all this together. By the way, I got on you guys about not showing work for your surface area problems, but surface area problems had two parts. You had a base area, you had a lateral area, you had to add them together. For volume, there is no plus in that formula. So if you just want to write down the numbers you're plugging in and then put your answer in underneath, that's fine, because it's all multiplication. You can do it all in one step. But Carter Shannon, I would still need to see the numbers you're plugging in. I don't want to just see your answer. Okay. So tell me what you get at. Tell me where you're getting these numbers from. So Xander, back to you. What's half of 12?
6.
What's 6 times 5?
30.
And 30 times 9. Okay, and we're going to label that in meters cubed. Yeah, I know. It's an adjustment. Example C is a circular prism. We know it's called a cylinder, and it uses the same formula for volume, except we're going to plug in a different thing for capital B. Garrett, what am I going to plug in for the circle formula, since I have a circle base? That's right. And what is our radius? Good. And our height's going to be 6. Now, last time, every time we did a cylinder problem, we wrote our answer in terms of pi, because there was a pi on this side of the formula and there was a pi on that side of the formula, and you could combine them. But we only really just have one side to the formula here. So if you want to put 9 times 6 is 54 pi and then put your answer, that's fine. Or you could just put your answer. Because again, it's all multiplication. You don't need to combine this pi with another pi on the other side, because there is no other side of the formula. This is just volume this week. So we can just do 54 times pi is 3.14. You can use the pi button. It's up to you. I usually use 3.14. And that should be approximately, told you I'm going to get better at using those squiggly equal signs, 169.56. And what are we labeling this in, Deegan? Meters cubed. That's right. And again, that 54 is because it's not 6 times 6, it's 9 times 6. Remember, when you square a number, you're timesing it by itself, not by 2. Here's another triangular prism. Maddox, can you tell me how to find the area of our triangular base? Okay. And then what am I going to use for the height of this prism? Maddox. Okay. So the 1/2 actually cancels out with the 2 that Maddox gave me for the height of the triangle base. So I'm really just doing 5.5 times 2. Christian, what's 5.5 times? I'm sorry, I said times 2. What's 5.5 times 4? 22. And what am I going to label it in, Christian? That's right. And here's another cylinder problem. So my formula is volume equals capital B times H. Capital B is the area of our base. Lucy, what am I going to plug in to find the area of that circle? Squared. Yep. Squared. So I'm just doing area of that circle, power squared. Yep. And then I'm going to use the 8, not the diameter 8, but the height 8 for our H that I would plug into that formula. Lucy, what is 4 squared? 16, and I can do 16 times 8 times pi. I can do, again, you can write your answer in terms of pi, or you could just give me the answer. Who has 16 times 8 times 3.14, Sky? 401.92, and what's my label going to be? Inches cubed. Easy peasy. Again, please make sure you're showing your work. If you don't want to write the formula every time, that's fine. Again, I had to do that last week because I wanted you to, get to the point where you're memorizing those formulas. This one's not one that's super difficult to memorize. So if you just want to put your work, pi times 4 squared times 8, that's fine. This is a cube, a very special type of rectangular prism where no matter which base I choose, front base, bottom base, side base, doesn't matter. They're all the same size because they're all squares. So my length times my width times my height is going to be 4 times 4 times 4. Whether I use this formula, okay, its younger brother, this formula, which is really the same thing, just plugging length times width in for B, or its older cousin, this formula, which is a special formula that I can use only for cubes, which basically says, hey, you know that length, width, and height, they're all going to be the same on a cube. So just do side times side times side or side cube. So if you did 4 to the 3rd power, you're going to get the same thing. What is 4 to the 3rd power, Connor Kendall? That's right. What's my label going to be? Why did I put inches? Yes, you're right. Feet cubed. In fact, this BH formula is so useful that you can use it to find the volume of any prism as long as you know capital B on that prism. Yes, Lizzie? Well, as of right now, you'd only be able to find capital B on those 3 shapes. So if I give you a shape like this octagonal prism that I promised you, I would have to tell you what capital B was. So let's say it's 12. Let's say that H is 8. Lizzie, if I said capital B was 12 inches, since I want to use inches so bad, inches squared, and I said that the height was 8 inches, can you tell me what volume would be?
96 inches.
That's right. Yep, she's just going to take capital B, multiply it to H. You will have some homework problems that are going to be that simple. They give you capital B. Maybe it's not an octagonal prism, maybe it's hexagonal prism. They give you capital B, they give you H. The formula says I multiply those 2 together. Okay, so this next one doesn't really have us do any work for it. It just says that a cereal box, and yes, I drew that cereal box myself, by the way. A cereal box measures 6 inches by 2 inches by 9 inches. Explain whether doubling the length, the width, or the height would double the amount of cereal that the box holds. Well, this right here is the volume of that box of cereal without doubling anything, 108 inches cubed. If you double the length of the box, okay, if you double the length, that would make it 12 inches by 2 inches by 9 inches. Would that double the volume? Is 216 the doubled version of 108? Yes. In fact, it'd be like putting 2 cereal boxes side by side, wouldn't it? If I doubled that, well, maybe that's my picture. If I doubled this and just made it twice as long, it'd be like 2 cereal boxes side by side. If I double the width, well, that's going to take this from 2 to 4. Is that going to double the volume of the original box? Yeah. In fact, it's like buying one of those special ones you buy at Sam's Club or something where they come in a package like that. It's just doubling the width there. And then if I got really creative and doubled the height of the box, well, of course, it's also going to double the volume because now it's like two boxes stacked on each other. So of course, it's going to hold twice as much cereal as what any of the other dimensions doubled would hold. Okay, that's pretty obvious. So the answer to that is yes, it would. As you can see, doubling any of the dimensions, the length, the width, or the height is going to double the entire volume, because essentially all you're doing is taking this formula and at some point you're putting a times 2. Maybe it's the height you double, or the length you double, or the width you double. But since multiplication can happen in whatever order, you're just doubling the whole thing. This is where it can get a little interesting, though, a little dicey here. A can of corn has a radius of 2.5 inches and a height of 4 inches. Yes, I drew that can myself as well. It's really good. You can tell the texture on the leaves. You can tell it was professionally done. Got the cross hatching and everything. Explain whether doubling the height of the can would have the same effect as, so the same effect on the volume. So would doubling the height double the volume? Or would doubling the radius double the volume? Those are things we're going to look at here. So let's talk about doubling the height first. If I double the height of this can and make it 8 inches, would that double the volume? What do you think? It'd be like putting 2 cans on top of each other, wouldn't it? Yeah, of course that's going to double the volume, just like doubling the height on the rectangular prism. So doubling the height will double the volume. However, doubling the radius will not double the volume. Okay, here's why. If I do 2.5 squared, well, Oliver's doing it. Oliver's going to tell me what that is. That's the original radius, right? What is 2.5 squared? 6.25. If doubling the radius was going to double the volume, that means that 5 squared should be 12.50. Is 5 squared equal to 12.50? What's 5 squared equal to? 25? Yeah, that's a bit of a problem then. Let's try a different radius. Let's say the radius was 8. Well, okay, that's fine. 8 is fine. And then I double it. What is 8 squared? Anybody? 64. Okay. So if I double the radius, again, if this were to be true, if doubling the radius did actually double the volume, then my new radius squared should be 128. But that's not what 16 squared is equal to. Jacoby, what's 16 squared equal to? What's the relationship between 6.5 to 25 and 64 to 26? Sander?
4.
Yeah. Doubling the radius actually in effect quadruples. I'm not going to spell that right. Quadruple. That can't be right. I don't know. I'll have to Google that to see if that's right. It quadruples the volume, doesn't it? It doesn't double it. It actually quadruples it. The reason for that is because I'm running out of room to write this, but I'm just going to put it right here. If I take r squared and then double it using parentheses like that, we'll talk about this later this year because we're going to do a lot with exponents. But actually, when you have something like 2r, twice the radius, being squared, you actually take the exponent and you distribute it to the numbers in the parentheses. So it's actually 2 squared r squared. And what's 2 squared equal to? 4. So as Xander said, it quadruples it because you're taking, when you double the radius, it becomes 4 times the radius squared, not 2 times the radius squared. And so it quadruples it. Again, not super like detrimental to anything you're going to see on a quiz, but just important to know that doubling the radius because of the exponent there doesn't have the same effect as just doubling the height or the length, the width of a rectangular prism. Lizzie?
You spelled it right.
Did I?
Yeah.
Yes. That's a win for me. I haven't had too many wins today. I need to celebrate this one. It's been a rough day. Yeah. Why? Because I wasted all my pen grading Oliver's quiz. I just like picking on Oliver today. I don't know why. He's very pickable.
Oliver is very bullyable.
Apparently. All right. Now, I'm going over this next example because you're going to see one like this in your homework. So I just want to make sure. What's different about this next example isn't the fact that you haven't seen a cylinder before, but because they're going to have you convert from cubic feet into gallons. And we have a conversion here for that. It says how many gallons, not cubic feet, how many gallons of water does the water cooler bottle contain? Round your answer to the nearest whole number, which is really weird to have you round to that. But you're also rounding in gallons. So they just want to know to the nearest gallon, I suppose. So I know that the volume formula says to take my area of my base times my height, and my base area is that circle. So Deegan, if I want to find the area of that circle, can you tell me what the radius of that circle is? Yeah, that's right, 0.5 feet. So pi times my radius squared times my height of the water cooler is 1.7. So Deegan, that's going to give me some decimals, and I don't want you to round anything quite yet, but go ahead and do 0.5 squared times 1.7 times 3.14 and give me all the decimals you give there. Okay, all the decimal places. I know that we have to round to the nearest whole number, but I like to round at the end. The later in the problem you can, so if you can go all the way through the problem and round at the end, the more accuracy. The earlier in the problem you round, you go more accuracy you lose. And on big ideas, that could make a difference. What do you get when you multiply all these together, Deegan? Yes. All of them. Okay, 1.3345, and that's in cubic feet. That's in cubic feet because I did feet times feet times feet. So if you're wondering where my third one came from, I did the radius feet squared. There's feet squared. Then I did a third feet here. So just like we see over here on the board, we're going to get feet cubed out of that because I multiplied the radius times itself times the height. Now, that's not the answer. And even 1 isn't the answer. I know it wants the nearest whole number, but it wants the number of gallons. So I need to convert that. Every single cubic foot is equal to 7.5 gallons. So if 1 cubic foot is equal to 7.5, 1.3345 would be equal to how many, Lizzie? And what am I doing? That's right. And go ahead and tell me what that is and give me all the decimal places. So Lizzie, what is that going to round to the nearest whole number? Obviously 10. Yeah. And then now we can label it in gallons. I still want your answer to be labeled, but we're not going to use cubic feet since we just switched it to gallons, which means those water coolers that you see in office or something like that, they hold almost exactly 10 gallons. Okay. We have time to do one more problem, and it's going to be this one here with the movie theater popcorn bags, and then it looks like we'll have one more that we can do tomorrow when we come in. A movie theater designs 2 bags to hold 96 cubic inches of popcorn. Now, if they hold 96 cubic inches of popcorn, what dimension are they giving you? If they're telling you how much the bag holds, Xander? The volume. Do you care if you get one bag or the other if they hold the same amount of popcorn? No, you shouldn't care. You do care?
Yes, I do.
Why?
Because I like the, I don't know why, but I like the taller and skinnier bags because I just do.
Okay, fair enough. You might have personal preference.
I don't because it's personal.
True.
Oh, fair enough.
True.
Never mind, the shorter bag is better.
Okay, okay.
Exactly.
I would hate to get butter all the way up my elbow because I'm reaching at that last piece, right? And I'm a person that loads it up with butter as well, so that would happen to me. I would have butter all the way up here.
But that's the thing, that was like, that's why you eat the first half of it, and then you give it to the other person to eat the bad part.
Okay. So we want to find the height of each of these bags. Lizzie.
Also, they should let you bring your own popcorn and then they pop out popcorn for you and then they give you.
That's too much. You're asking too much
You're
out
not
of them.
allowed to bring your own food in. So
You're-
That doesn't stop it.
Yeah, I think that they don't do a really good job of checking, so you could bring like a steak dinner, and I think they wouldn't even know. So,
Yeah, like, what are they gonna do?
All right.
Airport security?
we're gonna use the bottom as the base of our bag because we actually have those dimensions. We don't know what the height is. We'll leave that H blank. And we can do 3 times 4 times H to find the volume of our bag. Now, the volume is actually given to us in the problem. It's 96. So by working backwards here, and we did this last week as well, but this is a lot easier to work backwards on, we can find our missing height dimension. Can someone tell me what 3 times 4 is? Anybody? Okay, so this is just 96 equals 12H. What do I have to do to get H by itself? Person,
Divide 96 by 12.
go ahead and do that for me and you'll get what answer? Shh, Carson's gonna give you the answer. It is 8, and because it's just a regular old unit, I'm just gonna call it 8 inches. Not 8 inches squared or 8 inches cubed, I already know the volume. Okay, for bag B, we're gonna do the same thing. We're gonna say that 96 is equal to 4 times 4 times H, length times width times height. What's 4 times 4, Jimmy? And what's 96 divided by 16? 6. So one bag is a little bit shorter. Okay. Now, again, if I'm the consumer, I don't really care as long as I'm getting out. Again, you might have a preference one bag or the other, but as long as you're getting the same amount of popcorn, it's really no big deal. But as the owner of the movie theater, one of the bags might be more expensive than the other one, whichever one has the most paper. So how do I find out which bag has the least amount of paper? Brady? That's exactly what I would do. Yeah. So because it's a rectangular prism, I'm going to use my surface area formula. We already know what the height is now, but you'll notice that there's no top on this bag, right? Okay. So B plus PH. We're not going to do 2B because there's no top. So the base is 3 times 4. We said that was 12 already. What's the perimeter? What's 3 plus 4 plus 3 plus 4? 7 plus 7. Maddox? 14. And we know the height is 8 on that bag. This is bag A. Maddox, what's 14 times 8? Okay, add 12 to that.
Please come to the office. Hannah Lindley, please come to the office.
100 and what?
And
24
Giovanni
inches squared.
Giovanni Donna Maria, please come to the
Let's
office.
do it for bag B now. Let's do it for bag B. The area of bag B's base was 16. And what's the perimeter of that square? 4 plus 4 plus 4 plus 4. Anybody? Anybody? Also 16. Yeah, it's one of those weird squares where the perimeter is the same as the area. That only happens for that square right there. And then I'm going to times that by its height, which Jimmy said was 6. So 16 times 6 is going to give us 96. 96 plus 16 is, anybody? Anybody? 112. So is there a bag that uses less paper?
Yeah.
It's bag B. So if I'm the restaurant or the movie theater owner, I'm going to go with bag B, which actually you guys told me that's the one you'd prefer, right? Yeah, perfect. Okay. So bag B. All right, we'll pick it up there tomorrow. Your guys' homework's on big ideas, and I know we didn't finish the notes, but I think you can power right through that homework. It is one of those where there's an assignment on one, there's an assignment on the other. You can do them on one piece of paper, or you can staple it, your preference. But one of the homeworks comes from the 7th grade book, and one of them cylinders come from the 8th grade.